Gravitational potential energy. Case 1. For the particle very near to the Earth's surface. Case 2. Case 1. The force of gravity is a conservative force and potential energy of a body arising out of this force is called gravitational potential energy. Consider the points close to the Earth's surface of the Earth at distances from the surface much smaller than the radius of the Earth. In such cases, the force of gravity is practically a constant equal to mg, directed toward the center of the Earth. If we consider a point at a height h1 from the surface of the Earth and another height h2 from the surfaces, the work done in lifting the particle of mass m from the first to the second position is W12 equals to force into displacement. Here shown H1 and H2, and H1 is very less than H1, H2 is very less than H. R is the radius of Earth, and equals to mg because force is given by mg into H2 minus H1, equation 1. If we associate a potential energy WH at a point at a height h above the surface such that WH equals to FGH plus W naught or W0, equation 2, where W naught is a constant. Now from equation 1, W12 equals to mg into H2 minus H1, mg H2 minus mg H1 equals to mg H2 plus W0 minus mg H1 plus W0. In the light of equation 2, above equation becomes W12 WH2 minus WH1, equation 3. Thus from equation 3 it is clear that the work done in moving the particle is just the difference of potential energy between its final and initial position. Setting h equals to 0 in the equation 2, we get W0 equals to mg to 0 plus W naught, or W0 equals to W naught. H equals to 0 means the point on the surface of the earth. So potential energy on the surface of earth is W0 equals to W naught. Again, we let the reference configuration of the system is that when the particle is at the surface of earth and potential energy in this case is considered to be 0, that is W0 equals to W naught equals to 0. Then the potential energy of the particle at a height h from the surface WH equals to mgh. Second, for a arbitrary distance from the surface of Earth, the potential energy of the particle Earth system is the negative of the work done by the external agent as the particle moves from infinity to the some finite distance. Consider a point outside the Earth. The force of gravitation on a particle directed toward the Earth of the Earth is F equal to gme by mr square, where m equal to mass of the Earth, m equals to mass of the particle, and r is the distance of particle from Earth center. Work done in displacing the particle by displacement dr vector is dw equals to f vector by dr fa into dr cos 0, or equals to fa dr equals to f dr equals to gme m by r square into dr. So total work done in the displacing the particle from r equals to r1 to r equals to r2 is W12 equals to r1 to r2 dw, or equals to r1 to r2 gme by m into r square dr, gme m r1 to r2 r to the power minus 2 dr, and gme m bracket r to the power minus 2 plus 1 minus 2 plus 1 to the limit r1 to r2. Solving this, finally we get W12 equals to minus gme m into under bracket 1 by r2 minus 1 by r1, equation 1. Let us associate a potential energy function wr at a distance r such that wr equals to minus gmem by r plus w1, equation 2. Now equation 1 can be written as W12 equals to minus G MEM by R2 plus G MEM by R1 equals to minus G MEM by R2 plus W1 minus G MEM by R1 plus W1. In the light of equation 2, every equation can be written as W12 equals to WR2 minus WR1. Thus, work done in displacing the particle from one position to another is equal to the change in potential energy of the system. Now setting R equals to infinity in equation 2, we get W infinity equals to W1. Thus W1 is the potential energy at infinity conventionally which is taken to be 0. That is W infinity equals to W1 equals to 0. Now consider the equation 1. If the particle is brought from infinity to the point r distance from the center, then r1 equals to infinity and r2 equals to r. And w12 equals to w infinity r equals to minus gme m 1 by r minus 1 by infinity equals to minus gme by r is potential energy system and is denoted by wr equals to minus gme m by r. It is also written as ur equals to minus g me m by r. That is, it represents the potential energy of a mass m with earth system. Now we have ur, that is potential energy at earth surface, minus gme by r, and ur plus h, that is potential energy at a height h from the earth surface, minus gme m by r plus h. This is hence change in potential energy ur plus h minus ur, and putting these values, finally we get here this value. So solving this, finally we get g mem h by r into r plus h. Since h is very less than r, hence r plus h equivalent to r. So we have gmm into h by r square equals to m into gm by r square into h, or m into g into h. Thus where gm by r square equals to h. Now potential energy of system of particles. If our system contains more than two particles, we consider each pair of particles in turn, calculate potential energy of the pairs as if the other particles were not there, and then sum the result. Example, potential energy of three particle system is U equals to U12 plus U23 equals to plus U13, given by minus G M1 M2 by R12, where R12 is the distance between M1 and M2, plus minus G M2 into M3 by R23, where R23 is the distance between particle M2 and M3. Similarly, we can write the third, minus G M3 into M1 by R13. Example, if the system is like this, then there will be, this can be written as like this, and finally this will be the potential energy of the system. If there are n particles in the system, then the number of pairs formed are n into n minus 1 by 2. Gravitational potential. The gravitational potential at a point in the gravitational field of a body is defined as the amount of work done in bringing a body of unit mass from infinity to that point. Thus, gravitational potential represented by Vp equals to work done infinity to that point by agent divided by m. This implies Vp equals to W infinity to R agent by m minus Gme by R divided by m equals to minus Gme by R. It is a scalar quantity, unit joule per kg. The potential at a point distance r from the point mass m is Vp equals to minus Gme by R. That is, if a mass is given and we have to find the potential at distance r of due to that mass, then this formula we have to use, Vp equals to minus Gm by r. The potential at a point due to several mass. If there are several mass m1, m2, m3 and we have to calculate the potential at point P, then this will be equal to the scalar sum of the potential due to invisible. For example, V equals to V1 plus V2 plus V3, where V1 is the potential at point P due to mass m1. Similarly, V2 is the potential at point P due to mass m2. And V3 is the potential at point P due to mass m3. And this will be given as minus Gm1 by R1 plus minus Gm2 by R2 plus minus Gm3 by R3. Here negative sign does not mean that this is a vector quantity. The negative sign represents that the energy is negative. Example, find the potential energy of the system. Here a system is placed on a square and all body have same mass m, and we have to find the potential at P. So we can calculate like this. Here we can get the value of distance from any mass at P is R, and R will be equal to L by root 2. So 2R equals to root 2 into L. Now potential energy between 1 and mass 1 and 2, that is this U12, and similarly potential energy 1 U13, U4, U23, U24. Each pair we mix with every mass, and finally we get this value. And solving, finally we are at minus Gm square by L into 4 plus 1.414 equals to minus 5.141 Gm square by L. And potential will be given as Vp equals to minus Gm by L by root 2 plus minus Gm by L by root 2, because point P is the distance from all mass is equal, that is R, and value of R is L by root 2. So potential at P due to this mass, this mass, this mass and this mass will be equal minus Gm by L by root 2 minus Gm by L by 1, adding minus 4 root 2 Gm by L answer. Now escape speed. The escape speed or velocity is the minimum speed with which a body is projected in order that it may just escape from the gravitational field of the Earth. That is, body should not return to the Earth's surface. Consider an object is thrown initially with a speed vi from a point at a distance re plus h from the center of the Earth. The total energy of the projectile at initial point is E equals to potential energy plus kinetic energy minus Gme by Re plus H plus W1 plus 1 by 2 m vi square. This is potential energy with reference energy, and this is kinetic energy, where W1 is the potential energy at infinity, because we choose the potential energy reference point at infinity. Suppose the object reaches infinity and its speed be there here, then the total energy of the projectile at infinity is E infinity equals W1 plus 1 by 2 m Vf square, because we have considered the energy at potential energy at infinity as W1, and this is the kinetic energy. So total energy E infinity will be given by this formula. By the principle of conservation, E equals to infinity, that is energy at both points should be equal. So it is written E equals to infinity. This imply minus g me m by re plus h plus w1 plus 1 by 2 m vi square equals to w plus 1 by 2 m vf square. This imply 1 by 2 m vi square minus g me m by re plus h equals to 1 by 2 m vf square. Equation 3. As RHS is a positive quantity with a minimum value 0, and so must be the LHS. Thus, an object can reach infinity as long as Vi is such that mvi square vi square by 2 minus g mem by r plus h must be greater than equal to 0. The minimum value of Vi corresponding to the case when the LHS equals 0. Thus, the minimum speed required for an object to reach infinity corresponds to 1 by 2 m Vi square mm equals to g mem by re plus h minimum. This implies Vi min equals to under root 2 g me by re plus h. If the object is thrown from the surface of the earth, then h equals to 0 and we get Vi minimum equals to under root 2 g me by re equals to under root 2 g me by re into re by re. To solve the problem, equals to under root 2 g me by re square into re, or g me by re square equals to g acceleration due to gravity. This value is g, so 2g re, which comes out to be 11.2 kilometer per second. Thus, if we project any body with this velocity, the body will not come out on the come back to the surface of the earth. The escape velocity for any planet or heavenly body is given by Vi minimum equal to under root 2 Gp into Rp, where Gp is the acceleration due to planet at the surface of the planet, given by formula Gmp by Rp square, where Rp is the radius of the planet, or Mp is the mass of the planet, Rp is the radius of planet. For moon, Vi minimum equals to 2.3 kilometer per second. So the escape velocity on the moon is 2.3 kilometer per second. Find the minimum speed of mass m so that it can reach body p. Here the situation is shown, and this body is of mass m and this is of mass 4m, but both have same radius, and a body is projected at this point that is on the surface, and the distance between the center is 6r. Then what will be the minimum speed to reach the body at point B? Let n is a neutral point, that is where the mass will experience net zero gravitational force due to both bodies A and B. If mass m is projected such that it reaches just right to n, it will be attracted by body B. For this situation, let V be the minimum projection velocity. Now to the energy at the surface of A, E equal to 1 by 2 mv square plus minus g mm by r plus minus g m 4m by 6r minus g mm into 4m by 5r. At neutral point n, the speed approaches 0. The total mechanical energy at n, En equals to minus g mm by r plus minus g m into 4m by 6r plus minus g 4m into m by 6r minus r. From energy conservation, Ea equals to En, and putting this value and so as n at n, force due to A and B on mass m is equal and opposite, so Fa equals to Fb. Now we can write g mm by r square equals to g 4m into m by r minus r square, which gives 1 by r equals to 4 by r minus r ka whole square equals to r minus r ka whole square by r square equals to 4, or this implies 6r minus r by r equals to plus minus 2. When 6r minus r by r equals to 2, this implies 6r minus r equals to 2r, or this implies 3r equals to 6r, or r equals to 6r by 3 equals to 2r. And when 6r minus r by r equals to minus 2, we get r equals to minus 6r, which is unacceptable value. Hence r will be equals to 2r. Using this value of r in equation 1, we get 1 by 2 mv square minus g mm by r minus 4 g mm by 5r equals to minus g mm by 2r minus 4 g mm by 4r. And solving this, the final value we get v square equals to 2 into 3 gm by 5 in 10r equals to v square 3 gm by 5r, or v equals to under root 3 gm by 5r. Answer.